Hello everyone, welcome to the second part of tutorial 0. In this section, we will learn about apply function and ggplot. So apply function is very important in R because apply function can be viewed as a substitute to the for loop. And in R, using apply instead of for loop is highly recommended because the efficiency is a great improvement if we use the apply function. You can't use a pipeline operator with a for loop when you are looping through a data frame. So notice that there are actually a lot of apply function in R. I mean, there are sapply, lapply, something like that. But I think, in my personal opinion, you only need the most basic apply function. You can do everything you want. Let's begin by checking the element of the apply function. We can see that there are at least 3 elements: the data x, and it can be an array, a matrix, a data frame, and the second parameter is the margin, and it's either 1 or 2. This value will determine whether your function will work by rows or by columns. And the third element is the function you want to apply on your data, and it can be a built-in R function or it can be a custom function like the lambda function in Python. Let's begin by a very simple case that, let's say we want to calculate the mean of each row or each column of the numeric data in the iris dataset. So we can use apply, and the data is the iris dataset, so it's on the left of the pipeline operator. Just use a dot in the margin, and we can use either 1 or 2 depending on the row or column we want to use. And here we can use the mean just for a simple case. So so when margin equal to 1, the calculation is by row. So we have the mean value of the sample length and petal length and the width, the two width. Okay, so if we change the margin equal to 1 to margin equal to 2, the result will be this. So this calculation will be by column. Wonder what if the function we want to apply have many parameters in it. For example, if we want to apply a random normal function, and you can see there are like at least 3 parameters that we can control in the function. So how can we apply this when we don't want the default mean or standard deviation? Well, actually, it's very simple. We just need to put the other parameters here after the function. Just put it here. So this statement will be like this. So it's like we will use the petal length as the mean in the random normal function, and the standard deviation will be 1. And for every petal length, it will draw 5 samples from the standard deviation, from the normal distribution. Is when you want to apply and customize function in using apply. So let's make a customized mean function. So we want to make a customized mean function, and we can just use the R customized function here, function x, and this x will be either a column or the row of a data, and depending on the margin value being 1 or 2. So if margin is equal to 2, the x will be the whole one column of the data. And if the margin is 1, it will be a row. So in this case, the x, the input, will be something like this. Okay, this is one input that will be plugged into the function. So when we want to do the mean, we have to use the curly bracket to take out the value in this row. Okay, so we have to do it like this. Like we have to take out each value from the x vector. We can get the right result. So this is the correct syntax. It's not like something like function and a B, C, D, and just A plus B plus C plus D divided by 4, something like that. No, this doesn't work. You need to remember that the input of this customized function is a row vector or a column vector, depending on the margin. We can validate that the result of the building mean function and our customized mean function are the same. By doing this, that the result of these two functions, the building sum function and our customized sum function are the same. Yeah, you can see the results are the same. Next, let's talk about the very useful plotting package, ggplot2 in R. So ggplot2 allows you to draw a plot by layers, and a plot will be consist by the data and the aesthetics, and aesthetics is the data you want to put on the x-axis or the y-axis or any other things. And then the third component is the geometry. So the geometry is like what kind of plot you want. It can be a line plot, a histogram, area plot, something. It can be anything. Like there are lots of different geometry in the ggplot package. So the steps to create a ggplot is very structured. So the first thing you need to do is to put the data into the ggplot function, and this will result in a ggplot object. So just execute this line and nothing will happen. But it's normal. Yeah, it's just R will create an empty plot, and then you can incrementally add layers. So for example, we want to add a layer of histogram about the petal width of the iris data. You just need to use the add sign to add a histogram. So for now, yeah, we have our first layer of our data, and a histogram is just a one-dimensional graph. So there's only one data in the aesthetic. Like if you are plotting a line plot or point plot, which are two-dimensional plots, you will need to provide more than one column in the aesthetic part. And if we want to add more layers, for example, I want to have two histograms, I just need to add another histogram here using the same code. So for now, we can see that there are two histograms on the same plot, and they will all be inside this A object. In different geometry plots, there are different parameters that you can control. So for example, in the histogram, you can control the bins, and there are also some other common variables and common parameters that you can control over the plot. For example, the alpha will allow you to control the transparency of the color, and fill will be the inner color, and color will be the outside color. So if I don't set a color to NA, for example, I set it to blue, you can see there will be a line covering the histogram. So I don't like this, and just if you want to set any of them to transparent, you just need to set it to an A. So you'll be like this. I want to show you some two-dimensional plots. The most frequently used plot in the multivariate analysis class are the line plots and the area plots. So line plot is very simple, just geometric line. And looking at this plot, you can set the x-axis to 1 to 150 and the y-axis to the petal width. So you will have your first line plot, your first line like this, and you can have maybe, let's say our prediction is just also 1 from 1 to 150. It will be like this, and you can set the line type for a line plot, like a bin for the histogram. So there are many choices of line type. You can search it on Google, like what kind of type you want. And also, it's very common that we want to plot the confidence interval or prediction interval of our prediction. And for this kind of thing, you need the geometry ribbon. And this will create an area plot. And the same thing is, the aesthetic of geometry ribbon is a little bit different. Like here, you only need one x-axis, but you need the minimum value and maximum value of y for each x. So it will be like this. gray areas are created by the geometric ribbon function, and you can see that the upper bound and the lower bound are controlled by the y minimum and y maximum value. You don't want, usually I will set the alpha of the geometric ribbon to like about 50%, because if you set it to 1, you cannot see what's your original prediction. Yeah, you can see your prediction in this example. Another very common task in visualization is to set different colors on your plot, and setting the color in ggplot can be done in 2 ways. So you can either set the color manually or by adding one more dimension of data to the aesthetic. So let's see this example. If you want to set the color manually, you can set it outside the aesthetic part. So you can see that I set the color equal to blue and black outside the aesthetic plot. So with these 2 lines, you will have 2 lines, and one in blue and one in black. Okay, but what if you want to set different colors for different species? Then you can just set the species in the aesthetic plot, in the aesthetic part. So you can see that color is like the 3rd dimension on the geometric line, and the result will be like this. You can see that with one line of code, R create 3 colors, but they are set by their species. You can see that the blue is the Virginica iris, and the green and the red are all different species. It also works for, like for example, a histogram. So if you want a histogram of sample length and in different colors, and they are by different species, you can type the code. Like this. But well, this plot seems to be very weird because the color is actually the outer line, not the inner color of a histogram. So you actually need to change the color to fill and set the color to NA. This is the result you will like to see. Parameters of the geometry function can either be set inside aesthetic or outside it. So like here, you can set the fill and the color, or maybe the alpha value can also be inside the aesthetic. It all depends on what kind of plot you want. The last thing is about adding the text part, like either the label, the title, or yeah, this just like this. So you just need the labs function, and then the y will be the y label, x will be the x label, title will be just any plot, and you can also set the legend name. So for example, in this p plot, the color is species, and maybe you don't want this name, you want to say iris, it will be changed to iris. If you don't want to change, just leave it blank or set nothing. Yeah, or you don't want this title, you can set it as, yeah, then this will disappear.